So let's talk about general rectangular prisms. So all of these here are different forms of rectangular prisms. And with this, again, I'm just going to write it again, is thinking about this base layer times height. And really that base layer is coming from an area that we're calculating. So we're finding this area and then multiplying by height as it kind of stretches up. So with these two here, you get kind of a visual for this of here's a rectangular prism, and this is truly rectangular because that base layer coming through there is a rectangle. So what we could do is, if you think about that base layer area, we're taking 7 times 5, which is 35. In that case, it would just be square inches. We're just getting this area. But then the idea is stretching that along the height of the prism. Again, if we think about kind of slicing this, if this was a cake, if you slice across there, you're getting this 7 by 5 rectangle every single time. And what you could do is create 11 slices, and that's what's being stacked up here, is this number of layers, which is coming through from the height, is the number of layers that we would have of that base. So if I wanted to find the volume, what I could do is take those 7 by 5 rectangles, so I have 7 times 5 for that area of 35, and then multiply it by that height of 11. And what that would do is give us the volume of this, because we take that base layer there and then you multiply it by how many times it shows up, which is the number of layers coming through. So with that, 7 times 5 times 11, and that'll be 385. And then cubic inches. I'm not going to calculate them here, but just to talk about surface area and tying that in to this as well. With a rectangular prism like this, it's just a matter of getting all those different rectangles, and you have those pairings. So like top and bottom would be the same, right and left would be the same, front and back would be the same. So if we wanted to calculate surface area, we would just use that formula from before. So now let's look at a prism that's a shape that we haven't looked at yet. So again, in terms of a base and thinking about like if this was a cake, if I cut across this way here, I would get this triangular shape each time. I would have these slices that are each a triangle going along this height of 16 inches. Sorry, I didn't want to get rid of that one there. There we go. So we have this base down here, which is a triangular shape, and this height of 16. So here you can see a visual for just this base layer coming through. And with this base layer, it's a triangle. So we would take 1/2, and then in terms of the triangular formula, we'd have this base times height. So this is a right triangle, I should say that too, that's important here. So base of 7.5 times 8. So 1/2 times base times height would give us the area of that base layer for that triangle. Now to make this a volume, what we would do is we'd start stacking them up, and the number of layers we would have would match up with that height. So if I want the volume for this, then what I would do is take the area of the triangle, so 1/2 times base times height, and then multiply by the height of the prism, which is that 16, and that would give me the volume of the figure. And we would plug that into the calculator, and that should be 480, and let's see, inches cubed. So this right here is a rectangular prism as well, because we have these straight sides coming through, which all make up the height of the figure. And then it has this base figure as well that it's repeating if we slice it up. All right, so let's look at these two down here. So these are twisted on their side, but the idea is that we have this base shape. So in this case, we have a trapezoid. And then it's this idea of if I kind of slice it up. So take a slice, we'd slice it up so we're seeing a trapezoid each time. So the height or the number of layers we would have goes along that 23 centimeters. So as a reminder, the area of a trapezoid is you take, there's base 1 and base 2, and you add them up, divide by 2 times the height. What's kind of tricky with these, and it comes up when we dealt with the triangle up above, is we have this terminology base times height. With this, I'm just thinking in terms of the two-dimensional figure that we're seeing here. So we see this 14.2, which since we have that 90 degree, that's going to match up with the height in our formula. And then we have 19.8 is one of the bases. And then the other base is coming through up here. Notice the number isn't marked there, but it lines up with that 13.5. So area of the trapezoid, what I'm taking is the 19.8 plus 13.5 divided by 2, and then multiplying by 14.2. That right there finds this area. So it finds the area of the base layer. Then to make this a volume, what I would need to do is then multiply by the number of layers I would have, or the height of the figure. So the height here is going to be 23. So let's look at plugging this into the calculator. So I'm going to separate up my fraction, and I'm going to have 19.8 plus 13.5 divided by 2. And then multiply that by 14.2 and multiply that by 23 to make it a volume. So 5,437.89. And that's centimeters cubed. Just to touch on surface area again, even though I'm not going to calculate it here, what you could see is if you wanted to find the surface area, so like we'd have 2 of those trapezoids, so actually partially calculated it, you would just take that formula and you'd have 2 of them. And then everything else is rectangles. So like you'd have this 23 by 13.5, you would have this 23 by 14.2, you would have this 23 by 19.8. So you just start adding up those different areas. A tricky one would be getting this side here. You would need the length of that right there. However, with properties of triangles, you could find that. I'm not going to go too far into it, but just to kind of, if you wanted to try it out, what you could do is see how the 13.5 comes through there. And then this would just be 19.8 minus the 13.5. And then you have this height of 14.2. So you have this right triangle, you would have 2 of the side lengths, and then with Pythagorean theorem, you could find that third side length. And then you would have the dimensions for that rectangle too. Same thing up above here. If you wanted to find the surface area, well, you would have 2 of those triangles, which you'd have the formula for right there. And then you would start having rectangles. So 7.5 by 16, 8 by 16, and then you would have this big piece back here, and with that you would need the hypotenuse. But if you have the 8 and 7.5 with Pythagorean theorem, you could solve for the hypotenuse to get that dimension there. So we have ways of finding surface area here, just not going to go through it while we're talking about volume. All right, one more here. So this one, we have our prism, and what we could see is this triangle coming through. Again, we could think of slicing this up. If I started slicing this way, we'd see that triangle coming through each time. So that's making this height, or these kind of layers, of 45 meters. So let's talk about the area of our base there. What I'm going to do is draw this to the side, because I want the area of this triangle, which is 1/2 times base times height. And what I could see is we have this base of 28. but I don't know the height. The height of this triangle is coming through right here, that right angle. So if I slice it like that, that's coming down right in the middle. So that means over here is just 14. And then I actually know the hypotenuse, which is 28. So if I'm looking for the height here, I'm going to need to use the Pythagorean theorem. So, and actually I'm not going to call that h, I'm going to reserve h for this 45 up above here. So let's just call that x. So 28 is the hypotenuse. So if I use the Pythagorean theorem, I'll have the hypotenuse squared equals x squared plus 14 squared. I'm going to go ahead and subtract 14 squared from both sides. Now I'm just going to plug in that 28 squared minus 14 squared into a calculator, which should be 588. And then I'll just take the square root of both sides. And then I'll round that, and let's say I go to 4 decimal places just to keep this accurate. So let's call this a 24.2487. So with that, what I just found is this triangle height here is 24.2487. So if I want the area of the base, or the area of this triangle, we take 1/2 times the base of that triangle, which would be the 28, times the height of that triangle, which is that 24.2487. So that finds the area of the triangle. If I want this to be volume, then what I would need to do is take that area of that triangle and then multiply it 45 times. So with that, we can go to the calculator and just plug that in. So we'll have 1/2 times 28 times 24.2487, or you could type in the square root of 588 if you want it to be even more accurate, times 45 for 15,276.681. So 15,276.681. Sorry, my memory is not that strong. Oh, good. Got it. And then the units would be meters cubed. And again, for finding, actually this one would be pretty easy to do surface area for, especially with this 28, 28, 28. We would have the area of this triangle pretty much already calculated there, and we would just need 2 of them. So you take those areas, and then you have this 28 by 45, and that occurs 3 times. So you just take those rectangles and multiply it by 3, and you would have your surface area all done there. All right, so there's our prisms. So you think of this base layer, which is a shape that we've calculated area for previously, and then just visualizing this height, which is going to be this kind of straight edge for how this shape stretches along. Like this, we have our triangle, and this 16 stretches it up. We have this rectangle, and the 11 stretches it up.